Alrighty, guys. So quadrilaterals. Like I say, we at this point in maths, we don't have to learn like any like super specific reasons, but we need to become familiar with characteristics of quadrilaterals, because later on in maths, especially if you plan on taking maths in grade 10, 11, and 12, knowing and understanding and being able to work with these properties is going to be really important. And we don't want to get to like grade 10 and panic because we don't know our quads. Okay, so hands up, pop it in the chat. What are quadrilaterals? Like, what do I mean when I say quadrilaterals? What does that mean? Oh, lovely. Love some hands. Oops. Okay. Oh, Yolanda, who is our lucky participant? Oops. So many things.
Sorry, I was just trying to read the comments in the chat.
Oh no, sorry.
But we have Lefika. Lefika was tell us Mugai.
Good afternoon, ma'am.
Hi.
Quadrilaterals are four-sided polygons.
Good. Okay, so just so that, because we've also thrown in a word there, polygon. Poly basically means many, and so we're talking about a many-sided shape. The quad part then specifically means four. So what we are working with is a closed four-sided shape. Right, we'll get there eventually. Okay, so anytime you've got a four-sided shape, and when I say closed, I mean like all of the sides like meet up with each other. There's no like open gaps between sides. Whenever we've got a four-sided shape, what we are working with is a quadrilateral. Okay, now, excuse me, one of the properties of any quadrilateral, it can be like a very basic irregular quad, it can be a super specific like square or rectangle, but one of the basic properties that we need to know is the fact that all interior angles add up to 360 degrees. And again, this is going to be something that whilst, oh guys, sorry, I've got such a frog in my throat. Whilst not necessarily something we're going to use a lot as a reason, it is going to be something that we're going to use more and more often, especially in geometry. So it's really good for us to know these basic properties. All right, so a basic quadrilateral, four sides, and if we add up all four of the interior angles, we're going to get 360 degrees. So now we're going to have a look at some specific quadrilaterals that we need to be familiar with. So again, I'm going to ask you to give me some properties as we go along, and we'll cover everything that we need to know as we look at each individual one. So the first one we're going to have a look at are, some of you will use the word trapeziums, otherwise we can call them trapezoids, but trapeziums, trapezoids, that's our first one that we're going to look at. So you can pop it on the chat or hands up. Can anyone tell me anything about trapeziums, either the ones I have here or just in general, anything you might know about a trapezium or a trapezoid?
Okay, our new Matthew.
Trapeziums are four-sided polygons that only have two parallel lines.
Awesome. Okay, so one of like the defining characteristics of a trapezium or a trapezoid is that there is one pair of parallel sides. Okay, now just remember this little symbol here means parallel. And guys, I'm mostly using like symbols and shorthand here because to write it all out is just going to take too long. So it's got one pair of parallel sides. Now remember, when we are working with parallel lines, and as Yolanda says, if you need to go back, all of the videos that we did on parallel lines are on Watobe's website, so you can go and have a look there. But we symbolize parallel lines with like little arrowheads on the sides. So on my diagram, those are the two lines that are parallel to each other. And remember, parallel means that they are running in the sort of same direction and they're the same distance apart from each other the entire time. They're never going to intersect or meet with each other. Alrighty, so that's a defining characteristic of our trapeziums. Now I've got two pictures here. So can anyone tell me what specific type of trapezium the second one at the bottom here is? Let's see. It's a very specific type of trapezium. Does anyone know what that is? You can pop your hand up or you can put it in the chat.
Lindsay, we are all yours.
Two pairs of side or parallel, or opposite side equals, or opposite side equals to 90 degrees, I think.
Okay, so I'm really liking the fact that we still have two sides parallel, and I'm liking the the comment of sides being equal, because this trapezium that we have here is actually what we call an isosceles trapezium. Now, if you think about what an isosceles triangle is, an isosceles triangle is one where two sides are equal. So in an isosceles trapezium, not only do we have one pair of parallel sides,
Okay.
we also have one pair of sides equal in length, and that'll be the other pair that aren't parallel. Okay, so an isosceles trapezium is one that is slightly more specific or slightly more specialized, I suppose you could say, in that it still has that one pair of parallel sides, but the other two sides are actually equal in length. And that's where the isosceles part comes from. But that's really all we need to know about trapeziums. So they're not really shapes we work with a lot. Sometimes they come up, but sort of the more shapes that we start to talk about are parallelograms and rhombi and rectangles and stuff like that, which we're going to get to. All right, so those are the characteristics of a trapezium or trapezoids that we need to know. The fact that there is one pair of parallel sides, and if you're working specifically with an isosceles trapezium, the two opposite sides are equal. All right, so take a screenshot if you need to. Let's have a look at our next type of quad. Okay. So our next quad that we're going to chat about is a kite. Again, not one that comes up often, but it does sometimes come up, and so we need to know its properties. And again, guys, whilst this year, this stuff isn't going to be heavily tested or heavily dealt with, it is going to become more and more important as we go on. So it's important that we just get this foundation going. Okay, so can anyone tell me anything about a kite? Anything you want? There's lots of characteristics we can go through. Okay, Tandor, tell me something.
They both have two equal sides.
Okay. Just two pairs of, yeah, and then?
Yes, ma'am, two pairs of equal sides.
Mm-hmm.
And I'm not sure if I'm correct here, but equal to 360, if I'm not wrong.
Okay, cool. No, perfect. So I'm going to start with the first characteristic that we've outlined. And Amanda has put on the chat something quite specific, which I quite like. In a kite, we have got two pairs of adjacent sides equal. Oh, that's not how you spell adjacent. That's not even a letter. Okay, now guys, adjacent means next to. So I'm just going to put that up here. Next to. So two sides that are right next to each other are equal in length. So what that means is that these two sides are equal, and then these two sides are equal, and we can see that those sides are adjacent. They're next to each other. The top two are right next to each other, sort of at that top corner, and then the bottom two are next to each other in that bottom corner. So we've got two pairs of adjacent sides equal to each other. As Tando also said, we know that in all quadrilaterals, if I add up all of the angles in this, inside this quadrilateral, I'm going to get 360 degrees. Okay, I can see on the chat, we've got some other, what are my words? guys, I'm sorry, my English has disappeared on me today. Other characteristics, there we go. From Matthew, we've got one pair of angles are equal. So one pair of opposite angles equal. And what's sort of important to note here is that the angles that are equal will always be between the two sides that aren't equal. So that seems like a lot of words. But basically this angle over here with the dot will be equal to this angle over here because it's between two sides that aren't equal to each other. It's quite clear from my diagram that this angle at the top very clearly can't be equal to that angle at the bottom because one is much bigger than the other. So we've got two pairs of opposite angles equal to each other. Okay, I'm seeing some things about diagonals, which is great. Where did I see something about diagonals? So Amanda's also put on here one diagonal bisects the other, which is awesome. And I'll chat about what a diagonal is now. So one diagonal is bisected. Oh, my English, my spelling, it's all gone downhill. And someone else has also put on the chat, and I just see things coming up. They bisect at 90 degrees. So the diagonals meet each other at 90 degrees. Right, so let's draw this stuff in. If we're talking about a diagonal, basically the diagonal is a line drawn from one vertex to the opposite vertex. So one corner to an opposite corner. And in quadrilaterals, we have got two diagonals. So those red dotted lines are my diagonals. Now, when we're saying bisected, what we mean is cut exactly in half, right? So if we have a look at our diagonal, we can quite clearly see that it's only one of them that's cut in half. This sort of horizontal diagonal is the one that's cut in half because the long vertical one very clearly has more length at the bottom or underneath the other diagonal than it does at the top. So it's definitely not cut in half. Okay, the other thing we said is that they intersect at 90 degrees. So here, where these two diagonals meet each other, I get a right angle. And remember, I can represent that with a little square. Oh, sorry. Okay, so kites, adjacent sides equal to each other, one pair of opposite angles equal to each other, and our diagonals meet at 90 degrees and one of them gets cut in half. Okay, so there are other characteristics that we can talk about. They're not overly important, so I don't think you need to stress too much about them. I'll pop them on here so that you know, but it's not something you need to worry too much about. Sorry. One diagonal bisects its opposite angle. So basically what that means is this diagonal cuts that angle at the top in half, and this diagonal cuts that angle at the bottom in half. So the angles at the top and the bottom of this kite are cut exactly in half. That's not a very important characteristic to stress about, so you don't have to worry too much. What you do need to stress about is the fact that a kite has the two pairs of adjacent sides equal, which is what we've shown on the diagram, and one pair of opposite angles equal, and the characteristics that we spoke about that relate to the diagonals. Again, this is not something that comes up a whole lot in terms of specifically kites. I've seen it come up once or twice, so it's never going to come up, but don't stress too much about it. But those are the general characteristics that we need to know for our kite. Okay. So take a screenshot. Sorry, I just left it at an awkward silence there. Take a screenshot if you need to. Okay, guys, and remember, if you experience load shedding, If you miss part of the lesson, come late, come early, whatever the case is, just remember that everything is recorded, and so you can get the recordings online. Okay, we know with load shedding, it's not ideal, and we do sometimes miss stuff, so you can get the recordings online. Right, so this has been a lot of information. Let's take a little break before we do our next ones. Sure, sorry everyone. So today I've got a brain teaser for you, not very mathy, but here's our brain break. Remember, if you're not going to do it, that's cool. Excuse me. But get up, stretch, move your body a bit, and get ready for the next bit of our lesson. So the brain teaser here is basically we need to try and guess the phrase that is represented by the pictures here. Hello, my Baba. What's wrong? My cat has joined us. You can put your answers in the chat if you want. Oh, I already see some hands up. Tandil, you're really close with 5, really close. Think about what the pie is in. Okay, both of my cats are now with us. Okay, Kakliso, do you want to tell us one of them, or do you have a question?
Hi, ma'am.
Hi.
Can you hear me?
I can.
Sorry. I can tell you 1, 2, and 5.
Oh, wow, on it. Okay, tell me one.
So 1 is tricycle.
Good, because there's 3 cycles, so it's a tricycle.
Yes.
Yeah.
And then number 2 is reading in between the lines.
Nice. Oh, I don't think I can write all of that. I'm just going to say between the lines. Nice. And
then 5 is apple pie.
Nice. Okay, so Tando, hopefully you see why I said you were close there. It is indeed pie, and I'm really glad that you picked up on that. The 3, 1, 4, 1, 5, 2, 6, all that fun stuff. But because it's an apple, it's apple pie.
Guys, this load shedding is playing with my mind. Guys, you're doing so great. I think there's one person who's not muted. And who answered again? Someone who answered just now is not muted. And then I'll have to check for them. Mute them.
Okay, so guys, just make sure you are on mute on your side. That'll help us a little bit. Wontley, do you have another answer for us?
Yes, ma'am. I think 3 is hoverboard.
How do you get that?
Ma'am, to me, it looks like hoverboard because of HO for hover, HOR for hover, and then BOD for board.
Okay. Well, I mean, like, listen, also, you guys are very different generations to me. That could certainly be it. That's also not how you spell hover here. I don't actually know how you spell hover. I'm going to go with that. So this one, and this is probably maybe a bit old for you guys, is actually Robin Hood, because there is a Rob in a hood.
Yeah, it's supposed to be Robin Hood.
I'll be honest, I did not get that. I had to Google that one. Right, guys, what about number 4?
Oh, go and Google now. Mwabista. Yeah, all yours.
Ma'am.
Hi.
Hi. Ma'am, may I please ask, where did we get the V for hoverboard?
So, okay, so I think like in terms of hoverboard, that's maybe something that you guys would see more than I would see. The actual answer for number 3 is Robin Hood.
Oh, okay. Thank you.
Oh,
Let's go, my pips. We have number 4 left before my Wi-Fi switch off.
Oh, shit.
Hello, you wanna give us the last one?
Yes, ma'am. Can I please try?
Tell me.
Ma'am, it's 1 million.
Awesome. Okay, so number 4 is 1 in a million
Well
because
done. Well
there
done,
is
Temo. 1 in a million.
1 in a million.
Thank you,
Well
ma'am.
done.
Nice, guys. You did well. I hope you all enjoyed my joke. I specifically made it about quadrilaterals.
It's funny.
Alrighty. Let us get back to our quads. Okay. Remember, don't stress if you don't get these brain breaks. It's just a chance for you to take a second away from the geometry. Alrighty, so let us chat about our next quad, which is a parallelogram. Now, guys, this is the one that's actually probably the most important to know. It's one that's going to come up time and time again, literally all the way up until matric. So knowing your properties of a parallelogram is super important. So, already I can see some characteristics on the chat, which is awesome, and I'm liking what I'm seeing so far. Let's maybe hear from some people what characteristics a parallelogram has. Do we have any hands? Why can I not see hands? Nkanyezi, tell me one.
Ma'am, I said a quadrilateral has its opposite sides parallel and equal to each other.
Okay, awesome. So this is one of like the really important characteristics of a parallelogram. So both pairs of opposite sides are parallel and equal. Okay, so parallel and equal. So what that means is this side is parallel to this side. Those are opposite sides. They are also equal to each other. So we use a little like strike mark. This opposite side is parallel to its opposite side, and they are also equal to each other. So this is one of the really important characteristics of a parallelogram. Right, what else did I see on the chat? I saw something about angles. Right, opposite angles are equal to each other. Well done. Opposite interior angles are equal. So basically this angle is equal to this angle and this angle is equal to this angle. Awesome. And I see as well, Amanda sent a message saying that our diagonals bisect, which is awesome. And we've spoken about what this means. It means it cuts them in half. Okay, maybe I should finish my sentence. Each other. So guys, what this means is if I draw in my diagonals, and I'm just actually going to do that in a different color. So if I draw in those dotted lines from one opposite corner to the other. Ooh. Okay, it's not going to be beautiful, but I'm going to try. Ooh. Okay. There we go. It's a little bit better. What that means is they get cut in half. Now they're not equal to each other, but they do get cut in half. So the diagonals cut each other in half. Okay, so those are sort of the really important characteristics that we need to know about parallelograms. In parallelograms, we don't have any 90-degree angles. That will then come into like rectangles and squares and stuff. But in terms of our parallelogram, these are the important characteristics that we need to know. Okay, Lungile, do you have a question? No, okay. Alrighty, guys. I know this is a lot of information, and that's why I'm asking you, tell me about them so that it's not hopefully just my voice that you're hearing and you can see each other's messages on the chats and all the rest of it. So take a screenshot of your parallelogram if you need. And let's have a look at rectangles. All right. So can anyone tell me anything about a rectangle? Anything at all? Kulumo, tell me something. I feel like we haven't heard your voice yet today. Kulumo, you here? Oh, there we go.
Ma'am, the opposite sides are equal to each other.
Okay, cool. So what's quite cool about the next few shapes that we're going to chat about is they're actually all parallelograms. So a rectangle is a parallelogram. It's a special type of parallelogram, but it's a parallelogram. And so what that means, as Nkulumo's just told us, all of the properties that we wrote down here for a parallelogram actually apply to a rectangle as well. So we've got both pairs of opposite sides equal and parallel to each other. Equal and parallel. So this side is equal to this side and is parallel to this side. And then the other two sides are also parallel and equal to each other. Okay, so that is one of those characteristics that we work with. I can see on the chat as well some more properties coming through, which is great. Well done. Sejo, have you got something else for me?
Yes, ma'am.
Tell me.
Its diagonals bisect one another.
Good, well done. Okay, so again, I'm just going to draw my diagonals in a slightly different color as we start to put things in. So the diagonals of a rectangle not only bisect each other, as Tejo has told us, but they are also equal to each other. So the diagonals are equal in length, so they are both the same length, and they cut each other in half, they bisect each other. Now, if both of them are exactly the same length and are being cut in half, what that actually means is that all the halves of my diagonals are exactly the same length. And that is because of the fact that the diagonals are equal in length. When they bisect each other, they all the little parts are then equal. All right, so these are some really good characteristics of our rectangle. We've got a couple more that we hopefully need to get to. So Kakliso, do you want to tell me one? Oh, okay. Nomi, can you give me another characteristic?
Yes, ma'am. All four are 90 degrees.
Good. Okay. So a really important characteristic of a rectangle is the fact that all of the interior angles are 90 degrees. Well done. I saw that on the chat as well. So well done, everyone who said that.
Y'all are doing really, really well.
Okay.
Internet is even beeping, complaining. You guys are doing great. Trying to hold on to this class, but
okay, guys. So these are the really important characteristics of rectangles that we need to know. And like I say, and what I'm going to do also because someone asked to go back to parallelograms, what we can see is that all of the parallelogram characteristics apply. Both pairs of opposite sides are parallel and equal, and that's also in a rectangle. The opposite interior angles are equal. Well, if all of them are 90, the opposite ones are equal to each other. The diagonals bisect each other. This is also true in rectangles. Rectangles are a little bit more specific in that they've got the interior angles at 90 and that the diagonals are equal to each other. But a rectangle essentially is a special type of parallelogram. All right, so take a screenshot. You've got both parallelograms and rectangles there, just in case you missed the parallelogram one. But take your screenshot and then we can have a look, hopefully, with enough time at our last two. All righty. Cool. Okay, so our next one we're going to chat about are, okay, I said rhombi here. I made some choices. They weren't great ones. Rhombi is basically plural of a rhombus. So you can write it there for yourself. When I say rhombi, I mean many rhombuses. That's all I mean. All right, so on the chat, I can already see hands going up. Tell me anything you know about a rhombus. Oh, lots of hands. Lindile, can you tell me something?
Opposite side are equal, or
Good.
angle equals to 90 degrees.
Okay, so there's a few there that we're going to put down. So let's start with the sides one. So again, guys, what's quite cool about a rhombus is it's actually a parallelogram. It's a special type of parallelogram, but it's a parallelogram nonetheless. So all of the characteristics apply. Now, I'm going to split up these characteristics to start with. So the first one I'm going to start with is the fact that our opposite, or rather, let's put this as two pairs of opposite sides are parallel. Okay, because that's a characteristic of a parallelogram. So we know that this side's parallel to this side parallel to this side. So that's still our continuation that this is a parallelogram. We also have now spoken about the fact that we've got equal sides. But what's special to a rhombus is that all four sides are the same length. So it's no longer just the opposite ones equal to each other. It's all of them are exactly the same length. Okay, so this is now a unique characteristic to our rhombus. Before we just had the two opposite ones equal and the other two opposite ones equal, but now actually all four of them are equal. Okay, Miolo, can you tell me anything else about a rhombus?
Hello, ma'am.
Hi.
Diagonals bisect the angles of a rhombus.
Okay, cool. With you. Sorry, there's so many words in geometry. Sometimes I have to take a second. Okay, so I'm going to draw in the diagonals here again in a different color. So here are my blue diagonals. I'm getting better at diagonals, slowly but surely. Okay, so the diagonals of a rhombus bisect the interior angles. So diagonals bisect the interior angles. My cat is doing weird things. And basically what that means is it cuts each of the angles inside the parallelogram or the rhombus exactly in half. So all of these angles get cut in half. And another sort of cool thing about our parallelogram, our rhombus's diagonals, is that the diagonals actually intersect, or rather I could say bisect at 90 degrees. So not only do they get cut in half, as we've spoken about, they also actually cut each other at 90 degrees. And that is another super important characteristic in a rhombus. The fact that those diagonals meet at 90 degrees. Okay, so that's going to be one of the defining characteristics of rhombi that we need to work with to get all my language right. Otherwise, we're going to confuse everyone. All right, Seho, do you have anything else or do you have a question?
Ma'am, I don't have a question. I wanted to answer.
Okay, do you have anything else that you want to add?
Yeah, ma'am. In my own words, though.
Okay.
I said diagonals bisect each other perpendicularly.
Okay, perfect. Absolutely. So another way to phrase the fact that they bisect at 90 is the fact that they do bisect each other at a perpendicular or in a perpendicular manner. Perfect. Well done.
Thank you, ma'am.
Alrighty. So guys, the last sort of quad we're going to chat about is a square. Now, squares are one of the most specific, oh golly, quadrilaterals that we're going to work with. So no, I don't know what's happening. So sorry, everyone. Squares don't come up like a lot, similar to the kites and the trapeziums, but they can come up. And so again, it's important that we know how to deal with them. All right, Sino, do you want to tell me something about a square? Anything? Sinkolo? Oh, let me ask you to unmute. Oh, no, okay, lost you. Oh, no. Oh, your connection isn't great. Try again for me.
The connection is really, really bad. It's okay. If you can hear us, you can put your answer or your questions on the chat. Okay, we're gonna try and answer. Sorry, I'm just reading all these chats and trying to answer as fast as I can.
Okay, so I'm gonna leave Yolanda on the chat. I'm gonna go to the hands up. Amzolile, can you tell me anything about a square?
Hi, ma'am.
Hi.
A square is a parallelogram with equal adjacent sides, and the interior angles add up to 90 degrees. The interior angles are equal to 90 degrees. Sorry. The interior angles add up to 360 degrees.
Good. Okay, so we got a lot of characteristics there. So let me get them all down. First thing is, remember, guys, a square is still a special type of parallelogram. So all of those characteristics of a parallelogram apply. So I'm going to start with both pairs of opposite sides parallel. Pairs opposite sides. So many words. Parallel. So this side is parallel to this side. This side is parallel to this side. And now we've also got the added thing of the fact that all four sides are equal. Now that's quite similar to a rhombus, right? So far these characteristics are the same as a rhombus's characteristics. But we then got the other characteristic that all interior angles are 90 degrees. And so if all four sides are equal and all interior angles are equal, then what I'm working with is a square. Because remember, I can also get a rectangle where all of my interior angles are 90. But if I have the added characteristic of all my sides are equal, then we have got a square. Right, there's definitely more characteristics. So I still see some more hands. Bakliso, do you want to tell me anything else about a square?
Ma'am, can you hear me?
Yes.
I just wanted to say that diagonals also bisect in a square, and they are also both equal to each other.
Good. Okay. Right. So our diagonals also have some cool properties. I'm going to do it in a different color again. Hopefully my diagonals get better. Look at that. So much better. Okay. So the diagonals bisect at 90 degrees. And they are equal to each other, as was said. So diagonals are equal and they bisect at 90 degrees. So the whole length of a diagonal in both cases are equal to each other. They cut each other or bisect or intersect with each other at 90. And because the diagonals are equal in length, it means that all of these little halves are exactly the same length as each other. And so all of that means that the diagonals that are equal in length bisect at 90 degrees. All of those interior angles exactly are 90 degrees. And this is, again, guys, where that very basic characteristic came up with the fact that in any quadrilateral, if you add all four angles up inside the quadrilateral, you will get 360. If we add 90 plus 90 plus 90 plus 90, we get 360. And so that is still a characteristic of our square. Alrighty, so we actually have all of our characteristics here. One that we don't yet have, but again is not actually super important, so I wouldn't stress about it, is the fact that the diagonals also bisect the angles that they cut, so the opposite angles that they go through. And because all of these are 90, technically they cut them into 45 degrees. You can write it down if you want, but I wouldn't stress too much about this. It's not something that we use all that often, but it is a characteristic that the diagonals bisect the angles. All right, so those are our characteristics of our square. And so we need to, again, be familiar with it so that if we get presented with a quad, we are able to hopefully identify it. All right, Secho, I see your hand up. Do you have a question?
Yes, ma'am. Ma'am, so if we write a test about quadrilaterals, will they like tell us to mention all the properties and characteristics of them?
So probably not. They would maybe ask you for like 2 defining characteristics of a shape. Asking you for all of them would be quite harsh. And then just think about what makes a square. Well, it's the fact that there's 90-degree angles and all the sides are equal. So they probably wouldn't ask you for all of the properties, maybe just like the defining properties or the like properties that are unique to that shape. So yeah, probably not all of them. That would be quite many.
Thank you, ma'am.
Okay.